Here's a good question where they ask you to find the zeros of the polynomial and state the multiplicity of each. Now, often when they ask that question, they'll give you a question like this. Say x squared minus 5x plus 6. So if you need to find the zeros, you need to factor this. So it'd be x minus 3, x minus 2 is equal to f of x. And then to find the zeros, I'd make f of x or y equal to 0. So 0 is equal to x minus 3 or x minus 2, and then I'd solve that equation. So a product of two things to give 0, each of those I can write as equal to 0. Okay, so here I'd have x equals 3, x is equal to 2. So I needed to do this work to get it factored so I could determine the zeros. In this case here, it's already factored. So I don't need to do anything with it. So I can set this equal to 0 is equal to 2 times x plus 8 squared times x minus 8 cubed. So now I solve the equation. And it's funny that there's a 2 out front there, but you can treat that just the same as any one of those other factors there. So you could say either 2 is equal to 0 or x plus 8 equals 0. Oh, and there's two of those, x plus 8 equals 0. And then x minus 8 equals 0. And there's three of those. X minus 8 is, you get the idea. So 2 is equal to 0, that's a false statement. So I can cancel that out. This will be x equals minus 8, x equals minus 8, and then over here I'll have x is equal to 8 3 times. So when they say what the zeros are, so my zeros are negative 8 and positive 8. If they want to know the multiplicity, that's just how many there are. So I would say the zeros are negative 8 with a multiplicity of 2 and positive 8 with a multiplicity of 3. That would be my answer. Now, a cool question to do in addition to that would be to graph that polynomial. So if you had to graph that polynomial, so something happens at minus 8 and something happens at positive 8. If I have a multiplicity of 2, that's where the graph comes and bounces. And then if you have a multiplicity, an odd multiplicity, that's where it does a bend. It still crosses, but it bends. Now, totally, I've got 2 plus 3. So I would have, if you were to FOIL that whole polynomial out, it would come out to x to the 5th plus other stuff, maybe 2x to the 5th, but the leading term would be an x to the 5th and positive x to the 5th. So the graph has to start low and end high, and it'll have 4 turning points. So 1, 2, 3, 4. So the graph's going to look something like that with these bounces and bends in there. So I'm going to start down here. I come up, and at minus 8, it does a bounce. So it comes up and touches the graph and bounces back down. Okay? And then it'll come back up at 8, and 8 is where it has a bend. So it'll come and bend right at that point and then keep going. Okay? Hopefully that helps you. You didn't need to graph it, but that's how you determine the zeros and their multiplicity. You basically can just look at it and answer it as opposed to doing a bunch of work. Hopefully that helps you.